Is it going? Francis, is the red light on?
Yeah, the red light's on. Hello, I'm Frances Crick, and the man behind the camera is none other than James Watson. Our school right now is in the midst of a huge science fair competition. Basically, all the science classes divide up into different groups. Each group chooses a science topic and does a project on it. It's pretty open-ended. Our team is choosing to do our project on the structure of DNA, which is a tricky topic because nobody quite knows the exact structure of DNA yet. So there's potential for this entire effort to fail. Which is why Jim is making this video. See, our group kind of already failed when someone didn't write down the right water content for the DNA, and we had sodium connecting the phosphates on the inside, and we didn't factor enough for the water, and then with the sodium in the water and the king's costumes.
Okay.
Anyways, our group was broken up for a little while by our teacher, Mrs. Bragg. Over there. But we're back together now, with the addition of our new team member, Peter Pauling. His brother Linus is also working on DNA. Linus won the science fair last year when he discovered the structure of protein, so competition is pretty stiff. And I gotta say, part of the reason Pete's on our team is so we can get in closer with Linus, know what I'm saying?
Francis.
Getting back on topic. Anyways, there are 3 teams working on the structure of DNA. Each one is using different methods to find it though, so it works out. Our team, James, Pete, and I, are the Cambridge team, as is designated by our team sign. We're using models to figure out the structure. Have some nice, lovely models there. See, last year when Pete's brother Linus won the science fair, he was looking at models to solve the structure of protein, which as he found is helical, which is relevant because we think DNA is helical, so we figured we'd use models and that would be a good method. And okay, I see you, Jim, I'm getting back on topic now. Right, 2 other teams. So the first other team is Linus's team. They're across the hall, it's the Caltech team. The second team is the King's College London team. Now, they're using X-ray crystallography to find the structure. Basically, they take pictures of DNA and use those and look at those and use mathematical methods to derive the structure from there. On this team, we have Maureen Wilkins. She's our favorite of the group. She's the nice one. And we have Rosie Franklin. Isn't she a peach? They also have R.G. Gosling on their team. We don't really know what his name is. Everyone just calls him Gosling. So, yeah, let the science begin. Good morning, Jimmy. Who's that with the camera?
Some freshman who's willing to do it. What's up with you this morning? You're awfully chipper.
Well, when you hear what Petey just told me, you'll be excited too. Apparently some guy in his brother's class was working on DNA last year. Erwin Chargaff, you know him? Yeah, I'm neither. He's a senior. Anyways, he was looking at DNA nucleotides and look at this.
So, the guy did tests on nucleotide ratios and different strands of DNA. It's interesting and all, but it's not like it really pertains to our project. It doesn't really matter if Saccharomyces cerevisiae has DNA that's 31.7% adenine, and we really don't care.
Okay, by itself, yes, that information is useless, but you said it was what, 31.7% adenine? What percentage of thymine?
32 point... Wow, that's awfully similar. And guanine and cytosine are scarcely 1% off each other as well.
Exactly. I mean, they aren't all the exact same ratios. Like Escherichia coli is, less adenine and thymine, more cytosine and guanine. But you look at all of them and you start to see the pattern show up that adenine is
always about the same as thymine, and cytosine is always about the same as guanine. And if we could figure out why they're the same, it may help us with the structure.
There's the bell.
Scram, kid, class is starting. Wait, it's not recording.
Yeah, no, look, it is. It says recording.
Then why is it black? Oh. Lens cap was on. There we go.
Hello, good people of the science fair. And hello, Maureen Wilkins.
Hey, Francis.
What's up? You alright?
I'm fine. It's just Rosie's being a pain. She doesn't want to work with me at all, and it's really messing with our group. I don't even know why.
That's too bad. You could try to get her kicked out of the group. You know, just wait until she makes a big mistake, like builds a model with 3 helixes and sodium holding the phosphates together on the inside. Watson.
Well, first of all, she's not even into making models. I tried to get her to do it, and she hates the idea, so that's just not going to happen. She doesn't make mistakes, though. You know, her pictures are just getting better and better, and I guess it's good for our group.
Except for it's not good if she can't even read her pictures. But doesn't she think the phosphate backbone's on the outside?
Do I think the phosphate backbone is on the outside of the DNA molecule? Well, I don't know. Do you think that camera would hurt if I threw it at your face? Yes. Yes, I think the phosphate backbone is on the outside.
There's no reason to be mean about it, Rosie.
I wouldn't have to be mean about it if you two weren't so stupid about it. I mean, look at the data. It's the only logical place for the backbone to be.
Yeah, she's got the whole backbone thing going on. We just don't get along, I guess, but she's leaving as soon as she gets her work all finished up and gets it clear with the teacher.
That's good. Is she taking her work with her?
No, she's actually leaving it here.
That's good. So, I mean, in the end, you get to build models, you get her pictures, Rosie's out of your group. Just takes a while.
Yeah.
So, it's all good. Hey, any new discoveries? You find the structure yet?
No.
No need to be pissy with me. I'm just asking. I mean, our group just got back together too. It's bound to be a little rocky at first. We just need to, I don't know, compile a list of what we do know, you know? Write it on paper, get it out there. Maybe that'll give us some ideas.
Suppose it couldn't hurt. We know.
There are 2 main parts of DNA, the sugar phosphate backbone and the nitrogenous bases. The phosphates in the backbone are negatively charged. Don't give me that look, Jim. Write these things down.
All right then. Okay. All right. There are 4 nucleotides. Okay, separated into 2 groups. Pyrimidines are cytosine and thymine,
And purines are adenine and guanine. Okay, pyrimidines have a single ring structure. Purines have double ring structure. I cut you off there because you were mocking me, and frankly, I don't appreciate that from the guy that lets to create exploded DNA. Where were we? Oh yeah, nitrogenous bases. We also know the Char-Graph rule, so that, you know, in any given molecule of DNA, there's about the same number of adenine as thymine, and same for cytosine and guanine. You know, if we only knew why.
Hey guys, I thought I'd find you in here.
PD, what's up?
Nicked these off the printer this morning.
What's this? Your brother's paper, nice one there.
Francis, this isn't funny. What if he's right? Our whole project goes down the drain.
Still the tape.
It's on, right?
Yeah.
Yeah. Red light's on. Here, Francis, let me see this paper. Look at this. He's completely wrong. Triple helix sound familiar to you?
I don't know, did he use sodium to bind the backbone?
Very funny, but no. He's got a similar idea though. Instead of using sodium, he's using hydrogen bonds to hold the phosphate and the backbone together. If those weak things break apart, the whole molecule would completely fly apart. And the best part?
It's not even an acid the way he has it configured. I've been waiting all these years for my brother Linus to slip up. And it's finally happened.
Not an acid? He doesn't know that DNA stands for deoxyribonucleic acid, right?
Hey, so this morning we found out that Linus Pauling's proposed structure of DNA is completely wrong. So that's really great news because that completely puts his team out of the running. And so now I'm in front of the dark room about to tell Maureen and Rosie and Gosling the news. So here we go.